Hello, this is Mr. Huber. In this lesson, we're going to continue looking at exponential functions and graphs, and we're going to see how the different transformations can affect what those graphs look like. So we're going to see some equations that might look a little more complicated, something like what you see here, okay, where you're going to have different values along with the x in the exponent. You might have a value added or subtracted to the equation. And we're going to see that in order to graph this, we're going to go back to just looking at the y equals ab to the x. And then we're going to understand how that h and k just shift the graph, translate it left and right by h units, and then up or down by k units, depending on the signs of those. And we're going to talk about that here when we see some examples. So remember in the original equation here, the x minus h, so that's going to be something to keep in mind on, because if you have x minus 5, for instance, that means it's going to go to the right 5. Because your h value is actually just a 5, because the minus is already here. So keep that in mind. That can be something that's a little tricky. And so we'll see how that plays in when we do these graphs. This first example, okay, we want to graph it, and we want to describe the transformation. We want to see how it's shifted, changed, transformed from the original parent graph, just y equals b to the x. Okay, that's the parent graph. When we talk about a parent graph, y equals b to the x is the basic. A value would just be 1. We don't have anything added or subtracted. That's our basic parent exponential function. In the one that we're looking at here, again, we want to boil this down and just look at how would I graph the equation y equals 2 times 3 to the x. Forget about the minus 4 and minus 1 for right now. So let's just make a table of values. And we're going to still continue with negative 2, negative 1, 0, 1, and 2. And plugging those in, we're going to plug them into this equation here. Okay? We're not worried about plugging anything in with the minus 4s and the minus 1 or anything like that. So right now we're just doing y equals 2 times 3 to the x. And so if you put a negative 2 in for x, that's going to be 2 over 3 squared, so 2 over 9. So this would become 2 over 9. And if you have decimals, that's fine. If you're using them, put in your calculator and get decimal answers, you can do that. Okay. Then we have 2 over 3. We put a 0 in. 3 to 0 is 1 times 2 is 2. 2 times 3 to the first would be 6. And then 2 times 3 squared, which is 9. So 2 times 9, which is 18. All right. Keep in mind, again, right here, this is the y-intercept of that parent graph. Y equals 2 times 3 to the x. And then we can see we're multiplying by 3 each time to get that next y value. Now let's look at how we can use this to graph the original equation we were given, y equals 2 times 3 to the x minus 4 minus 1. Okay? So if I plot those points I have originally, I'm going to shift them all to the right 4 and down 1. To the right 4 and down 1. So when I set up my graph here, I want to look at that and understand that I'm going to shift these points to the right 4 and down 1. So I'm still going to have values that go up to 18, down 1 is still at 17. So I don't want to count by 1s, I'll be off my graph. So I'm going to count by 2s. Okay? So I'm going to set my graph up counting by 2s. And our original points I'm going to plot, just let's start out looking at it. I'm going to plot these points first. Okay? And I'll do them in red. So I'm going to go by 2s. I'll mark that on here. So I'm going to go 2, 4, 6. Okay, and in my x values, I was count by 1s. So my original here is going to be negative 2 and then comma 2 ninths. So negative 2 and 2 ninths, right around there. Negative 1 and 2/3, so negative 1 and 2/3, right around there. 0, comma 2. 1, comma 6. And 2, comma 18. All right, and if I graph those points, I'm going to see an exponential that looks something like this. All right, again, leveling out on the left side there as it gets closer and closer to the x-axis, and then on the right side going up forever, just increasing in y values. Okay. Now let's look at shifting those points. So now I'm going to graph in blue this equation. I don't need to make a new table. I don't need to do anything except take all these points that I just graphed and shift them to the right 4 and down 1. So I'll start with this point here. I'm going to shift this to the right 4. 1, 2, 3, 4. I'm going to go down 1. So right down here. Remember, I'm counting by 2, so don't go all the way down to here. I'm going to go down 1, so right down around here. All right, so I'm going to graph that point over 4 and down 1, and I'll have a point right there. Next point, I'm going to shift over 4 and down 1, be right around there. And then I'm going to take this point, I'm going to shift it to the right 1, 2, 3, 4, and down 1. It's at 2, so it's going to come right in here, right, to 1 now. So I can graph that point right there. Take the next point to the right, 1, 2, 3, 4, and down 1 would be right around there. And then my last point, 1, 2, 3, 4, and down 1. Right, so I took every one of these points and I went right 4, down 1, right 4, down 1. And now if I graph the curve that I have, I'm going to see it looks very similar to the one I had before, except it's shifted to the right and down. Okay. And you're going to see it's leveling off still. It doesn't just go down forever. You don't just draw this graph and have it keep going down here forever. It's still going to level off. Okay. Where is it going to level off? Well, if this graph was never going to reach 0, this is shifted down 1. This blue graph is never going to reach -1. So we have an asymptote that goes right across here, a line that approaches at -1. Okay, we could draw that in here if you want to. Let's do it here. So I would draw in an asymptote, that maybe goes like this at -1, right? And dropped it down there a little bit. So there we go, at -1. So that graph should look just like the one we had in red, except it's shifted to the right 4 and down 1. So you're not doing anything different here to set up this table of values, right? This is what you've been doing and working on. Make your table of values, and then just understand how we're going to take all those points, and you don't necessarily even have to draw this red curve in. Maybe just plot the point and then move it over. Okay, but it can help. You can see that this red curve looks the same as this blue curve, just shifted, translated. Okay, so how do we describe that, right? Don't forget the second part, describe the transformation. Okay, so there's 3 things to describe here. What the A value is doing, and then what the H and K values are doing. Okay, the A value of 2, if this is just a 1, right, like we have here, it'd be a 1, right? The 2 stretches the graph vertically. So anything here that's bigger than 1 stretches the graph vertically. So if we want to write these out, it's a vertical stretch. Okay. It's shifted or translated. It's fine, whichever word you use. Okay. Right 4, down 1. Okay. That's your description. Describe. That's what we've got right here. Okay, so we drew the graph and we've written the description of what is happening based on the A value and the H and the K. Okay. All right, let's have you see another one here and try this out. See what you think is happening to this. See if you can draw the graph. See if you can get the description down. And then you'll play it and see if you're on track with it or not. Okay, so where do we start with this? Well, we're going to make a table of values of x's and y's. Okay? And we're going to make it just the same as we would have before. Okay? Except, right, we're going to use this as 1/2 times 3 to the x. We're not going to worry about that +1 and +2 there. All right? So the first thing we do is we'd have 1/2 times 1 over 3 squared, right? Because put a -2 in there, right? That 3 to the -2 becomes 1 over 3 to the 2nd. So that's 1 over 18. Okay? So we have 1 over 18. And if we have 3 to the -1st, that'd be 1 over 3, so we're going to have 1 over 6. And we put a 0 in, 3 to 0, 0, and then we'd have 1/2. We put a 1 in, that'd be 3 over 2. We put a 2 in, it'd be 3 squared is 9 over 2. 9 over 2. Okay. If it helps to see these as decimals, 1.5. Maybe when you go to graph them, it's easier that way. That's fine. Doesn't matter. All right, so now we go to graph those points. All right. We're going to understand we're going to shift to the left 1 and up 2. So left 1 and up 2, we can count by ones here. We're not going to be anything off our graph from negative 10 to 10 if we do that. So our whole grid, we're going to go by ones. Right? So we're going to have negative 2 and 1/18. That's really close to 0 there. Negative 1 and 1/6, also pretty small values. 0 and 1/2, right around there. 1 and 1.5, right there. And then 2, 4.5 is right around there. And so we can draw our graph here. And leveling out. And there's our graph. That is for this. Y equals 1/2 times 3 to the x. Now, let's graph this one here in blue. Okay? So how are we going to do that? Well, we're going to shift everything to the left 1. Okay? This means we're going to the left 1. Plus 1 here, because it's a minus. Okay, but it's x minus h. So it's x minus negative 1. All right, so our h value is negative 1. So we're shifting to the left 1 and up 2. So I'm going to take all these points. I'm going to go to the left 1 and then up 2. So that first point would go right around there. Left 1, up 2. Left 1, up 2. And we keep going left 1 and up 2 for all of our points. And we've got our new graph here. If we want to look at what the asymptote would be, right? Our asymptote is normally on the x-axis, right? It would normally be right along here, right? That our graph will approach this, but it's never going to get to 0. That red graph will never get to 0. So now the blue graph we shift that up to is never going to get to 2. Okay? So we would have an asymptote along here that our graph is never going to reach. So when we draw it, we want to have it leveling out there. So it's going to come down here through those points, and then it's going to level out and never reach a value of 2. Okay? And so there's our graph of 1/2, 3 to the x plus 1 plus 2. It looks complicated, but when we boil it down, we break it down, make it look a little bit like what we've been doing, and then just shift that graph. All right, and then we want to describe it. So the description, that 1/2 is a compression or a shrink, okay? Because it's something between 0 and 1. When it was bigger than 1, it stretched the graph out. Now it's compressing the graph, okay? And then it's translated left 1, up 2. There's our description. Okay, so I want to be able to describe what that translation is that we're seeing, the transformations. All right, before we might look at another example here with a couple other things to be aware of, a little corner trivia. Okay, before Comerica Park, Tigers' home stadium, they played at Tiger Stadium. What was it called before it was called Tiger Stadium? A couple pictures of that stadium, a couple older photos from what was Tiger Stadium before they moved to Comerica Park. It was originally known as, excuse me, as Navin Field. The owner of the Tigers, Frank Navin, named it Navin Field. It opened the same day as Fenway Park in Boston in 1912. Okay, so that stadium opened in 1912, and then it was renamed Briggs Stadium in 1938 when the new owner of the Tigers, Walter Briggs, wanted to name it after himself. So kind of a popular thing there. And you buy this stadium and the team, name it after yourself, I guess. And he expanded the stadium, actually had a seating capacity of 53,000, added in these second decks along here. They had to take out a couple streets outside the stadium, add in these second decks when Briggs took over. And then in 1961, ownership changed hands again to John Fetzer. He didn't name it Fetzer Stadium. He actually called it Tiger Stadium. So Navin Field in 1912 to Briggs Stadium, and then Tiger Stadium from 1961 till it stopped hosting Tiger games in 1999. So a long time, 1912 to 1999, at that same location. And it was called The Corner because it was at the corner of Michigan Avenue and Trumbull. So people would say, we're going down to the corner, game at the corner. And although the stadium's knocked down, that field is still there. There's still the field playing surface there that Little League teams use and people can use. And actually, interestingly, hosted, it said Go Lions here, not because the Tigers used to be called the Lions, but because the Detroit Lions played their home football games from 1938 to 1974 at that same location. So the football field went kind of across this way, if you can imagine here. This is right field deck out here. So the Lions actually played there for quite a while as well. And just an interesting little numbers thing is Tiger Stadium here, okay, this Tiger Stadium had 11,111 home runs hit in it during the time it was open. So really interesting. After all those years, 11,111, 11111 for home runs hit at that stadium. Let's have you try one more here, exponential graph. Okay, you want to graph it and then be able to describe the transformation. All right, so hopefully you've given this one a go, and if you did and made a table of values for it, again, we make our x's and y's. We're going to plug in -2, -1, 0, 1, and 2, and we're going to plug it into -3 times 2 to the x. Okay, we're not forgetting about that plus 2 that's there, right? Just ab to the x. Graph the ab to the x, and then we'll shift it. Right, so if I plug a -2 in there, right, we're going to have -3 times 1 over 2 squared, right? 2 to the -2nd. Remember what that means in terms of making it a fraction? And then also keep in mind that negative. So it's -3 over 4. So it's going to be -3 over 4. When I plug a -1 in there, I'm going to get -3 over 2. Plug in a 0 is -3. It's 2 to the 0, still 1 times -3. Plug in a 1, -3 times 2, again, -6. And then 2 squared is 4 times -3 is -12. And we're going to be shifting these to the left too, right? That means we're shifting to the left too. There's no k value, so we're not shifting up or down at all. So we're going to shift to the left too. We want to keep in mind here we're going to go down to -12, so we might want to count by 2's on our axis again for the y's. So I'm going to count by 2's, 2, 4, and 6, and same on the negatives, -2, -4, -6. X value still will count by 1. So our first point is going to be -2, comma -3/4. So -2 and then -3/4. -1 and -3 over 2, that's -1.5, if that's easier for you to kind of figure where that goes on your graph. Okay. And remember, we're counting by 2's, so not quite at -2. 0 and -3. Then we have 1 and -6, again counting by 2, so 2, 4, 6 right to there. 2 and -12. Right there. Okay. So when I graph this, and it's going to still level out and not reach 0, even though it approaches it. You'll never get a y value of 0 for that. Now, when I go to graph this equation here, we'll do that in blue. Okay, we're going to see that the points are all going to be shifted just to the left 2, not up or down at all, just to the left 2. So the first point will shift to the left 2. Second point will shift to the left 2. Right, and keep going. We just shift all these points to the left 2. Okay, and then we can draw our graph through them. And it's still going to level out and not reach 0. Okay, so you can see how those graphs just shifted to the left. Looks pretty much the same. And now to describe the transformation, okay, so we talk about translated left 2. Let's write that part down first. We should be familiar with that. Okay, it's translated or shifted left 2. Okay, the -3. So the 3 part means it's a stretch. Okay, and the negative part, when you see a negative here, and we can see normally our exponentials, right, would be going like this, but when we see we have a negative a value, we noticed, right, it goes like this. So that's a reflection across this axis. Okay, this is the x-axis. We're taking what would normally be a graph going like this, and we're flipping it over down on the other side of that axis. So it's a reflection, okay, across, and this is the x-axis. So we want to make sure we understand. Again, when we see the equation, that's no different. We saw that we had negative a values before. Now we want to put it more into words, understand what it means for the graph, and how we can use that to help us in making sure we have an accurate graph, we can describe the graph, and we understand we can start with our more parent AB to the x graph and then just shift based on our h and if we had a k value up or down.